AJ 104 Learning Activity 4, Problem 2.12. Cite along a CC bond of propane and draw a Newman projection of the most stable conformation. Draw a Newman projection of the least unstable conformation. So we must note that we analyze one carbon-carbon band at a time and ignore the conformations along other bonds. So propane contains 3 carbon. So in carbon 1, we will have 2 hydrogen and CH3 or methyl, which is our third carbon. That's why our parent name is propane. And it is bonded to carbon 1. In carbon 2, we have 3 hydrogens. So we are going to cite carbon 1 and carbon 2. So the third carbon, which is propane, will become a substituent in Newman projection. Now this is our stable conformation or the staggered, and the carbon-hydrogen bond is as far away as possible. So this is our carbon 1 in front, and our carbon 2 is the back carbon. The least stable conformation is as close as possible. So the carbon-hydrogen bond is as close as possible. Problem 2.16. Propose skeletal structures for the following molecular formulas. So letter A, C4H8, that is butene. Butene is an alkene and we have a double bond. So we have 4 carbons, 1, 2, 3, and 4. And put a double bond here. And we put a double bond here. So every carbon has 2 hydrogens. So 2, 4, 6, and 8. Letter B, C3H6O. So that is acetone or propanone. The compound, as we can see, consists of 3 carbon atoms, 6 hydrogen atoms. So 1, 2, 3 carbon atoms and 6 hydrogen atoms, 2, 4, 6. And we have here a substituent or the functional group of oxygen present in the formula. So this is oxygen, a substituent. Letter C, C4H9Cl. So this is chlorobutane. Carbon, 4 carbon, 1, 2, 3, 4. And we have here a substituent of chlorine.
Good evening, everyone. Welcome to Organic Chemistry. I am GCG Monopolio, 18 years old, from Baslay, Dawin, Negros Oriental, taking Bachelor of Science, major in Agronomy. So now, I will explain the answer in Lesson 3, Problem 2.10. And in Lesson 4, I will explain the answer in Problem 2.20 and Problem 2.21. Now, I will explain the answer. Welcome to Organic Chemistry. AG 104. Lesson 4. Problem 2.20. Draw cis-1-chloro 3-methyl cyclopentane. So this is the drawing of cyclopentane. And cis is same substituent on same sides. So this is the chloro, 1-chloro, and this is the 3-methyl. 1 carbon and 3 hydrogen. And this is the 1-chloro. So that's all. And then problem 2.21 in lesson 4, draw both cis and trans isomer of 1,2-dibromocyclobutane. So this is the drawing of the cis. Trans is opposite side. So this is the cis. The cis is same substituent on same sides. So this is the bromine and this is the bromine. So same sides. So that this is the drawing of cis. And this is the trans. Trans is opposite side. So this is the bromine and this is the bromine. So trans 1,2-dibromocyclobutane. And this is the cis 1,2-dibromocyclobutane. So that is the answer.
Problem 2.18. Give IUPAC names for the following cycloalkanes. Determine the parent chain. Number the substituents of the ring beginning at one substituent so that the nearest substituent is numbered the lowest possible. If there are multiple choices that are still the same, go to the next substituent and give it the lowest number possible. Name the substituents and place them in alphabetical order. Problem 2.19. Draw structures corresponding to the following IUPAC names. So, first is 1/3 butyl 2-methylcyclopentane. It is called cyclopentane because it has 5 carbon on each side of the line. The second is 1,1-dimethylcyclobutane. It is called dimethylcyclobutane because it has 4 carbon and the carbon one is methyl. Third is 1-ethyl 4-isopropyl cyclohexane. It have 6 carbon, so it is called hexane, and carbon 1 is a methyl, and carbon 4 is the isopropyl, so that it is called isopropyl cyclohexane. The last is 3-cyclopropyl hexane. It have also 6 carbon, so that it is hexane, and then in the third carbon is a structure of a cyclopropyl, that's why it is called cyclopropyl hexane.